Hey guys, so here's the notes for 5.2 day 1. We're going to be able to describe the end behavior of polynomials. So we've dealt with, basically, you've already talked about lines in Algebra 1. We've talked about quadratics both in Algebra 1 and Algebra 2. Now we're going to be talking about functions that have degrees of 3 or higher. Those are going to be our polynomials. Now, before we can get into that, we need to talk about what is a polynomial function. Now, there needs to be two things that needs to be satisfied, probably three as well, in order for a function to be a polynomial. First, a function whose exponents are whole numbers. Now, what does these whole numbers represent? Basically, whole numbers are going to be 1 or higher, okay? So that means this can represent like 1, 2, 3, 4, 5, 6, 7, 8, all the way, okay? That means our exponents can't be variables, okay? They can't be fractions or decimals, and they can't be negative numbers. So you might want to write that down. So can't be negative, a variable, or fraction / decimal. Okay, that's what that means. Okay. Now, what about the coefficients? They're saying that coefficients have to be real numbers. So remember in our quadratics, we talked about imaginary. Imaginary is with I. So any number that doesn't have I. So basically, real numbers just can't have I. If you do, that's not a real number. Everything else is good. So you can have radicals like square root of 2. You can have pi. You can have fractions like 1/2, 3/4, 1/3. You can have decimals. Anything, that's fine. Now the last thing, and really you won't see this too much, is where our a value, which we're going to be calling the leading coefficient, that cannot equal to 0. And really your leading coefficient is never going to be 0, okay? Now, we have some examples here of what is a polynomial and what is not. So notice f of x equals 3x to the 4th plus 2x cubed minus x plus 5. This is a polynomial. Because, 1, notice that the exponents are whole numbers, so 4, 3, and 1. And notice that our coefficients are real numbers, so 3, 2, -1, and the 5. So this is what we call our constant term. That means it's going to be the number without the variable. Now notice the example of not being a polynomial. We have 9x to the 4th minus 5x to the -2nd plus 3. Let's look at exponents. Yes, we have a 4, but notice the 2 is negative. Remember, we have to have whole numbers. So the exponents can't be negative, a variable, or a fraction decimal. So this doesn't work because one of our exponents is a negative. Now let's talk about terminology, because I will be using this quite a bit, so you need to make sure you understand these words. Okay, standard form. This means exponents are in descending order, so we go from biggest to smallest. So notice we do that where in our polynomial, we go from the 4th to the 3rd. This represents to the 1st power, so if you don't see an exponent, that means 1 to the 1st power, and then our constant. So this is in standard form. Okay. Now the next one is what we call leading coefficient. It's going to be the coefficient of the first term when the function is in standard form. So in this case, because this is in standard form, our leading coefficient is the 3, okay, because that is going to be our first number on our first term. Now the degree of a polynomial, that's the exponent of the first term when the function is in standard form. So in this problem, our degree is going to be 4 because, first of all, that's the largest exponent. So another way you can say this is that it's going to be the largest exponent in standard form. Okay, so 4 is our largest or highest exponent. Okay, last term is the constant. So this is a term with no variables. It should be your last term when the function is standard form. So here, we kind of already talked about this. So we said the leading coefficient is 3, okay? Because basically 3x to the 4th, that is our first term. in standard form, because remember we go from biggest to smallest in our exponents. Okay. Okay, degree. So basically our degree is going to be the largest exponent. So in this case, it's going to be 4. And then the constant term, that's going to be our 5, because that doesn't have a variable with it. Okay, now what we're going to do is use this information to determine if these functions are polynomials, and if so, we'll write them in standard form and state the degree and the leading coefficient and the constant term. Okay, let's look at 1. So we have h of x equals x to the 4th minus 1/4 x squared plus 3. Okay, 2 things need to be satisfied. 1, are the exponents whole numbers? Well, we have 4 and 2. So yes, those are whole numbers. Okay, now our coefficients have to be real. So notice on x to the 4th, that coefficient is going to be a 1. So it's 1, negative 1/4, and 3 are those real numbers. Yes, they are. There's no I, so they are real. So yes, this is a polynomial here. Okay, so now what we need to do is write this in standard form. So we got to go from largest exponent to smallest. Now for us, this is actually already written in standard form, so that's nice. X squared plus 3. Okay, now what we need to do is state the degree. So I'm going to put D for degree, then LC to represent leading coefficient, and then constant CT for constant term. So our degree here is going to be the 4, because that's our largest exponent. Okay. The leading coefficient is going to be 1, because that is the number in front of our x to the 4th. And then our constant term is going to be the 3. Okay? Okay, let's go ahead and do the next one. We're actually going to skip 2, and we're going to go to example 3. Okay, we're doing the same thing. We got to see is 5x squared plus 3x to the negative first minus x. Is this a polynomial? Well, let's look at the exponents. We have 2. Oh, but we have a negative exponent, okay? Remember, we can't have any negative exponents, so no, not a polynomial, because we have a negative exponent. Now, you don't really need to, on your homework, write the explanation, but I'm doing this for the notes so you understand why this is not a polynomial, okay? So definitely write this down on your notes, so then when you are doing your homework assignments or studying for a test or quiz, you understand why certain functions are not polynomials. Okay, now what I want you to do is pause the video and try example 2 and example 4. Okay, let's see what you got. So let's look at g of x. So we have 7x minus square root of 3 plus pi x squared. Okay, first thing is we need to decide, are the exponents whole numbers? So on the 7x, know that though we don't see a number or an exponent, that is an assumed 1, okay? Anytime you don't see a number on the exponent, that's an assumed 1. So our exponents are 1 and 2, those are whole numbers. Now we need to decide, are the coefficients real? 7 is a real number. Square root of 3 is also a real number. The reason it is because it doesn't have an I. Remember, real numbers don't have I, imaginary numbers do. And pi, that is also a real number because it doesn't have an I. So our coefficients, yes, they are real. So this is a polynomial. So now what we need to do is write this in standard form. We have g of x. So our largest exponent is the x squared. So we have pi x squared, then plus 7x, and then our constant is the square root of negative 3. Or, sorry, negative square root of 3. Okay? So now let's figure out our degree, our leading coefficient, and the constant term. Okay, our largest exponent is a 2, that's the degree. The leading coefficient is pi, and then our constant term, the one without a variable, is negative square root of 3. Okay, let's try example 4. So we have x plus 2 to the x minus 0.6x to the 5th. Now let's look at the exponents. They have to be whole numbers. Okay, we have a 1. Oh, notice we have a variable for our exponent. Remember, we can't have this. So no, not a polynomial. Because we have a variable for an exponent, and that doesn't work, okay? Okay, so now that you've learned about what is and is not a polynomial function, in our next part of the video, we will be talking about in behavior.